Okay, hi everyone. Hello everybody. I think I'm gonna start. Hello everyone. How are you doing? I hope you can all hear me. So I think I'm gonna start because I'm seeing that it's 2 minutes past the hour, and I'll keep on accepting other people as I go along. So if I'm a bit distracted as I'm speaking or doing something, just know that, hi Scott, thank you so much. Just know that I'm busy accepting people, because what we're trying to do is make sure that we don't get hacked. So we put in place a measure to see who's coming into the room. So people need to be admitted when coming in. But I'm gonna start now so that we can begin with the proceedings of the day. Just know that we are recording the webinar, so it's gonna be available on YouTube. So you don't have to stress about that. I'll share the link at a later stage as well with everybody. Okay, so good afternoon, everyone. My name is Pablo Abelchauke, and I'm a training and outreach coordinator based at H2A Bionet, the Cape Town node, under the leadership of Professor Nicola Mulder. And I am part of the H2A Bionet Seminar Series Task Force, whereby we organize monthly webinars. And this is the first webinar for 2021, or the first webinar for the year. So thank you so much for all of you for joining us, for today's webinar with Dr. Evan Floden, who is the CEO and co-founder of Seqera Labs, and he's also a founding member of the Nextflow project. The theme for today's talk is Fair and Workflow Management, and the title of today's talk is Massively Scalable Fair Workflows with Nextflow and Tower. Okay. The talk will take place for 40 to 50 minutes, and at the end we'll have about 10 to 15 minutes of question and answer as well as discussion. So just a few ground rules to try and control what goes on in the room and to make sure that we have some order. I'm going to kindly ask that if you have a question, please either raise your hand or type it in the chat box while a speaker is speaking. Do not speak over him, because then that creates confusion and stuff like that, and we don't want any of that happening. I'm also going to ask that you mute yourself if you're not speaking. So for some people, I see I'm able to mute you because I'm the host, but I kindly ask that you do it yourself. If you know that you're not speaking, kindly mute yourself so that it's easier for all of us. So those are just the ground rules. I'm just going to read a bit of the abstract. I sent it in the ad. So there's an ad that went out in social media and on our mailing list as well. But I'm just going to read a bit of the abstract, not all of it because it's a bit long. So if you want to read the whole abstract, you have to go to the ad and find it. So as I said, the title of today's talk is Massively Scalable Fair Workflows with Nextflow and Tower. Nextflow is a popular open source workflow management system for development and deployment of data analysis pipelines. It simplifies the use of multi-scale containers and allows seamless integration with commonly used batch schedulers and as well as built-in support of cloud computing services such as AWS Batch and Google Cloud Life Sciences. During the years, it has evolved to address the growing requirements from the community and the need to manage the increasing complexity of omics data analysis pipelines. This presentation by Professor, or rather Dr. Evan Floden, introduces the key features of DSL2 and the advantages it provides to workflow developers. So just a bit of his biography, or rather of his biography. Evan Floden is the CEO and co-founder of Seqera Labs and founding member of the Nextflow project, as I said before. His role at Seqera Labs is executing on the vision of simplified scalable analysis pipelines in the cloud. Dr. Evan has experience bringing transformative healthcare solutions from ideation to market through roles in the biotechnology and medical device industry. He holds a PhD in biomedicine for work on large-scale sequence alignment. His broader interests encompass everything at the intersection of life sciences and cloud computing. Without further ado, I'm going to give Dr. Evan Floden the mic and the platform to speak. Dr. Evan, go ahead and give your presentation. Thank you so much for agreeing to do this.
Great, thank you very much. Thanks a lot for the introduction there. Let me just share with you my screen. Hopefully you can all see this. First, I'd like to say thanks a lot for the opportunity to speak, and also for Scott in particular, who invited us to give this talk. Maybe I'll start with a little bit of background on myself and how I kind of came about to be doing this. My background was much more in biology. Was really interested in biology as a kid. Maybe you might be able to tell from my accent, but I'm not really from Barcelona or Spain, where we're based. I'm originally from New Zealand, and I was working did my undergraduate there, and then really just saw there was an opportunity for biology to become much more digital, and wanted to come and learn bioinformatics and learn these skills. So I had the opportunity to move to Europe to do this. Went to Italy, studied bioinformatics there, where I met my was to be future supervisor, who was working on a piece of software which you may have heard of called T-Coffee. And T-Coffee is a multiple sequence alignment tool, so for doing heaps of sequences. And in the lab, part of my PhD project was to really do these really massive alignments. So we were trying all sorts of crazy combinations and trying to get better alignments through that. And what it turns out is there was a guy sitting beside me in the lab who was, really looking after the infrastructure, the kind of technology, how we were deploying it. He was like the kind of IT guru in the lab. And it happened to be Paolo Di Tommaso, who is the creator of Nextflow. And at the time, Paolo was just sort of began toying around with Nextflow. And the kind of story really begins then of this ideation around how can we take this analysis, these tools, the kind of things that we were putting together, and run them not just on our cluster, but run them on anyone's cluster, on any cloud. And how can we do this in a way which is kind of efficient and which is going to make all of the annoying things around the infrastructure much more easy. So that's the kind of idea of how it came about. So a bit of history on where that happened. That was when we were at the Center for Genomic Regulation, which is a research institution in Barcelona. So it's kind of right on the beach there. It's a super nice place. If you ever get the chance to visit, I'd recommend that you go there. And kind of as part of that, over several years, the project grew. We got some interest from people who were using Nextflow more sort of outside strictly academic use, and the kind of broader use was growing inside like biotechs and pharma, etc. So as part of that, we really wanted to make sure the project was sustainable and kind of was able to grow outside the purely kind of academic setting that we were in. And this is why in 2018, we created the company Seqera Labs. And Seqera's real job or mission is really about the Nextflow project and supporting that through all the ways that we can. So maybe a little bit of history. Sorry, I was put on mute there. I went back and looked at some of the initial conversations we had, and I see that there was a conversation with Scott way back over 4 years ago. So this was in December 2016. Long time when Nextflow was probably just over a couple of years old at the time. The project was kind of slow, but it kind of shows that there was a growing community, which has obviously grown a lot over the years. And there's a kind of mutual interest between Nextflow and H3A Bionet for developing these kind of tools and developing these kind of tool sets so that consortium, so that groups of users can essentially collaborate and then use those collaborative tools in a wider system and not have to duplicate a lot of the effort around in that. So I'll kind of start from a beginning of, imagine that you don't know so much about workflows. I'm sure that I think that there's been some workshops done on Nextflow before, but hopefully I'll try and provide an overview picture for people who haven't really know too much about Nextflow. The concept is pretty simple. In science now, and particularly in bioinformatics, we have a lot of data. We kind of need to process this data through a series of tools. And those tools do some transformations on that data. Sometimes they bring it together. Sometimes they spread it apart. Sometimes they do some action on it. And then it gets processed through many of these and we get some kind of output, a report, a CSV file, something that we want to do some further science on. And it's really that kind of part of the workflow, part of the kind of science that we're focused on, the part where we're chaining together tools into what's called a workflow here. This is a nice example of one, but it's very idealized. So typically they don't really look exactly like this. They can be much more complex. And you go into the details of these things, they can become very sophisticated. So this is a parasite genome annotation pipeline from the Sanger Institute. And you can see each one of those circles there is a different tool or a different script or a different process, we call in Nextflow, for operating on that data and performing this analysis, so analysis pipeline. And this means that these things are quite difficult to manage. So imagine that you took this pipeline here and then you worked on it, did your science, etc. And then you're like, okay, how am I going to publish this? How can I give this to my collaborator who's in another country using different infrastructure and they can run and get the same result? And this is one of the core challenges that we're trying to solve with Nextflow, is to enable that kind of ease of use from the user perspective, from the researcher, scientist perspective for doing so. And how it comes about and kind of the problem that we have, I guess you can summarize this as into a much wider problem. And that problem is that we all have very large data sets now. All the data sets that we have, particularly in genomics, are growing. What we're often doing is splitting that data up and running the data with the same tool many different times. So this could be, I have 100 samples which I need to operate on, which I need to run through my pipeline, and each of them will go through the pipeline separately. So this is what we call embarrassing parallelization. You can split the problem up and run it in parallel over the different tools. Those tools themselves, though, they are not often standard tools. These are often things that are something I've downloaded from GitHub. Maybe it's a script that the former PhD student in the lab has given to me and I have to reuse this or kind of put this into my pipeline. It could even be some commercially available tool. It could essentially be anything. And we have to put that tool into our massive pipeline now. And with that, we have to kind of do something with it. We have to kind of put it and make use of it for doing so. Finally, this creates a massive complex dependency tree. I remember when I first kind of got into bioinformatics, a little bit before containers and Conda existed, you were spending, like when you went to do an analysis, you spent half of the time just installing the tools. And this was a really common problem that some of the techniques that we've solved with Nextflow kind of remove that. And that kind of dependency problem can create conflicts. And that's really just installing on one machine. So you get into a whole bunch of these common problems that everyone is facing. And kind of a way to solve that is what we were going after with Nextflow. This is just an example of what that previous pipeline was made up of. However, it's not just as simple as like, I want to run my paper, I want to write my paper and use the results like this. There's also the problem of reproducibility. The fact that if I publish this research now, how can someone else be sure that what I've done is correct? Or how can I even reduce or redo that same analysis with a completely different data set? How can I validate that? And this is a paper which was showing that in order to reproduce a typical computational biology paper, it took around 280 hours. And this is 280 hours where you already have the methods section, which is very specific, but it's telling you what you have to do to kind of reproduce that result, and it's only getting more difficult. It's only getting harder to do so. Okay, you can kind of think of this, and I'd like to think of this as kind of a jigsaw puzzle for doing so. The problem is even slightly worse than this, though. It already sounds bad enough, but the problem is worse in the sense that even if you do have all of the software, so I know all the software which I'm using in my pipeline, I know all the scripts, I know all the command lines. Even if I was going to replicate it on a different machine, different computer, different cluster, different cloud, it's not guaranteed that I would get the same results. And this is what we were able to show in the original Nextflow paper here, is that if you do an analysis, say on Mac or on Linux, you can end up with different results, even with everything else exactly the same. And this is because there's underlying differences in those libraries. So you can end up, in this case, with a gene being annotated, the start position of a gene being a different location, or even the number of transcripts which you call differentially expressed to be different based on those numbers. And this is just two pipelines which we just picked out of the blue, and we're able to show that this can happen. So this complexity is only sort of existing in many other places as well, and it's something that we obviously want to control for. Okay, that's just like one part of this kind of fair data pipelines that we're talking about, and that's like the reproducibility part. But there's also many other aspects of these pipelines and kind of characteristics which we want to improve. In this slide here, it talks about cloud, but when I say cloud, I really mean distributed analysis. So this could be your cluster, it could be a series of computers, it could be anything. It's essentially just trying to say in an external system. So reproducibility is pretty obvious. We all want reproducible results. What we also want is portable results. This means that I can share my pipeline with you and you can run it on your machine. We also need these things to be scalable, because as these pipelines get bigger, you may want to run a small test data set. Maybe you want to develop the pipeline locally on your laptop. And then when it comes to do the production run, you need to run this in a very scalable manner. So in a huge space. And therefore you need this kind of ability to run the same pipeline across different scales. Finally, a lot of people are using these pipelines for biomedical research, but also in the clinic. And in these situations, the validation of these pipelines is incredibly important. You need to be sure of the result that you're getting, and you need to be able to validate that result against some set of tests, and as well as being usable. And this means that these pipelines ideally should not have to be used just by the person who wrote them. It's very common for bioinformatics tools to be not so user-friendly, let's say. You are a developer of a tool or a pipeline, you create it for yourself, only you know how to run it. When in reality, these things should be able to be used by people who just want to kick off some jobs against some specific new samples that they have. Maybe they don't know anything about the pipeline, as well as system administrators who want to control these pipelines via APIs. So you have a whole spectrum of users somewhere in between there who want to be able to use these pipelines. And this is the kind of things that we're trying to solve now with Nextflow. Okay, so all of that was a kind of a lead up to how do we get to here? What's the reason why we're doing this? Now I want to kind of show you a little bit about how it works and kind of how we try and solve these problems. Nextflow has two fundamental parts to it. One is the Nextflow script, which is a kind of a language. You can think of this as a language to write these pipelines. And then you have a runtime, which is kind of how these pipelines are run or where these pipelines are run. In the first part, the script, the kind of how you write Nextflow, you write code in any language. So if you have Bash, Python, R, any of the scripting languages which you use, you can write your code in that. You don't have to rewrite this for Nextflow. You then link what we call these processes together with channels, and channels are a special data structure, which I'll show you in a moment, and you define the dependencies of those processes using containers or Conda. that is kind of all wrapped up typically in a Git repository, so something like GitHub or whatever hosting solution you use, and the pipeline then can be run on any of the supported platforms using the Nextflow runtime. It looks kind of subtle here, but there's something important happening, is that in theory you should be able to run any Nextflow script on any of the different platforms that are supported. So there's a difference and there's a clear separation between the script and the configuration. And keeping these things separate is really what enables the portability and the scalability of Nextflow pipelines. Okay, I just want to go through a few kind of, let's say, different things that Nextflow has compared to some other workflow tools. So you may have heard of some tools such as CWL and WDL or WDL, which are specifications. These are a syntax, a language for writing pipelines. You may have also heard of something called SnakeMake, which is a pipeline tool for writing which has some more similarities to Nextflow, but some differences as well. And I'll try and point out here some of what those differences are between the other common solutions and kind of why Nextflow is unique in this way. So first of all, it's a DSL. So this means it's a domain-specific language. It means that we've taken an original programming language, which is Groovy in this case, and we've added a special syntax on top of it, which is the Nextflow language for writing these pipelines. Why is this important? Well, this is important because it enables the pipeline developer to access an underlying programming language if they need. So you don't have to, you're not stuck within this Nextflow kind of box of what's able to be done. You have the ability to import, to use the underlying language. However, to write a Nextflow pipeline, and I'll show you in a moment what it looks like, it can be incredibly easy as well. Very simple, because we've created essentially all of the syntax for writing these pipelines quick, for prototyping fast, for developing this way. This is quite different from something like a specification that you'll see, which can often be very verbose because it has to account for every use case of that pipeline. Finally, there's the parallelization model. This parallelization model is called dataflow. It's where the flow comes from in Nextflow. So dataflow programming, we call it. And this is a model which is able to essentially push data through your processes. So all your processes are linked together through channels. And this model is essentially reacting to that data being present. This is incredibly scalable. It means that you can have a pipeline of hundreds of thousands or millions of tasks because it's only reacting in the moment. You could compare it to something, if you're familiar with Make, like in SnakeMake, this is a very different model to that. It's essentially the opposite. And another thing would be like an iterative model. So when you write a loop, like I'm going for all of this and this is very different than that. So it's not actually having to do a loop through your data. It's actually the data forcing itself through. And I'll show some illustrations of that, which will make sense. It's also an idea that each of the tasks that we run, so each of the tasks which can be, SAM tools on this sample, except for example, when you run each of those, they run independently. So they run in their own environment and they run in their own work directory. So this means that they can be distributed in a very, let's say, clean way. It means that each task can be submitted and can be run completely independent of the other ones. It means you can have a pipeline where you run some of your tasks on your laptop and then some tasks get sent out to the cloud. These tasks are running independently in their own environment, and this really lends itself to the use of containers and was a kind of key insight as to being able to enable the containerization of our tasks in the future. Also, this thing which I mentioned before, which is the separation of the script versus the configuration. So basically the logic of the pipeline versus the configuration of where you run that pipeline. Keeping those things separate really enables that deployment and that portability. Okay, that's kind of high level kind of significant differences of the pipeline. Now let's take a look at what it looks like. So what does Nextflow look like? Start with considering a task like this. This is BWA mem. So BWA is a command line tool, something you might put in a script or you might run from the command line. Here we've got two inputs, which is a reference FASTA file and a sample FASTQ file. So we're essentially going to go to a line sample to the reference, and then we're going to pipe it to SAM tools. In Nextflow, imagine that you had this in a script. You can keep it, it can remain exactly like this. So you can have, for example, you'll wrap this script section now in a process, which we're going to give a name, a line sample. We have to define some inputs here. So I said before, we have a reference and a sample FASTQ as our inputs. We have an output, which is what we want to collect. It's what we want to take out of that process at the end. It's the result of the task. And then we have a script section. And that script section, you'll notice, is exactly the same as you would have in your command line. Fairly straightforward, although if Nextflow is new to you, there'll be one thing which is kind of looks a bit weird. And that is, what is these from and these into sections doing in the input and the output? And that's really where the magic happens here. Because imagine that I needed to now take this align sample task and use that downstream, so another process which is going to finish or going to happen after a line sample. I can use these channels to link them together. So in this example here, the BAM channel, which is the output of a line sample, can become the input of the index sample. And this explicit linking of them together via the channel is what's creating this data flow. It's essentially the output will be fired directly from the align sample into the index sample, and the execution of the second one will begin. Okay, the rest of that process there looks exactly the same as the downstream one. How does it look like in practice? So what we've actually been able to do now with DSL2, which is a kind of, it's an addition to Nextflow. It's an extension of what you can do with Nextflow. You can do the same thing, but you can really modularize the components. So you can take those process steps and use them. In this case, the quant step, you can use it in many different places. You can have that quant step and export it. You can have it in a different file. You can have a set of modules that you want to use and use those in different locations in your pipeline. So this is a sort of little example of DSL2. I would recommend, if you're looking to learn Nextflow, there's some really nice blog posts we did at the end of last year for learning resources. But I would recommend using DSL1 first and then kind of looking into DSL2 once you're kind of comfortable with this. It allows us to do some different things around actually not just modularization of the processes, but even of the workflows themselves. So a workflow can call a workflow. You can have much sort of deeper integration and some sort of neat tricks for writing a little bit more scalable and a little more readable pipelines themselves. Overall, the idea of this, and I hope it looks somewhat clear to you or somewhat easy to read, is that the language is designed to be used by scientists and by engineers and by people who don't necessarily have years of training in computer science. And we still want to enable the power and the ability to run very complex, very parallelized applications, but with a very simple syntax for doing so. Okay, that was a little bit on the syntax itself. I want to just take 1 second to talk about data flow, because I think it's a very important concept and it's very something that's quite different. So with data flow, we have all of our processes and they're essentially waiting there. They're waiting for data to flow into them. And as soon as data enters them, they fire off a task. So a task is executed. These channels themselves, they're called first in, first out queues. And those things enable the parallelization of our pipeline. Because they're all waiting there, they're able to happen and they're able to be executed in parallel. And the whole kind of graph, which you can kind of see on the right-hand side, Nextflow creates a graph of your pipeline. And as the data flows through this channel, it fires off the execution in the way that you specify. In practical terms, imagine that I had, oh, apologies for that. Practical terms, imagine that I had a channel and it had 3 files in it. This could be 3 FASTQ files or 3 FAST files. When those are executed into a process, because the fact that I have 3 of them, that process will execute 3 times. So I have 3 tasks which are executed there, producing 3 outputs. In the way that I would write that in Nextflow, I would create what's called a channel, which is this top line here. I'm creating a channel from some files. In the first case, I just have a single file. So sample.fastq. This means that fastqc here would run once. So I'm going to run this pipeline. fastqc is going to be executed once. If I change this and said, okay, now I want to run this on all my samples because I'm ready to scale it up, or I have some new samples, etc. From that point on, now the fastqc will run as many times as there is fastq files in that directory. And this is kind of where the scalability and parallelization comes from. This is another kind of diagram of that, which shows you that each of those fastqc files would be each of the fastq files would be fired through fastqc. And we can handle many different data structures. It doesn't have to be single files. It can be pairs of files. Very often you'll have, like reads, so like a first read and a second read. You can have much more complex structures with dictionaries, with maps, with different, any kind of data structure you can think can actually go inside of these channels and can operate them in the exact same way. Okay. That was everything on the kind of layout of the Nextflow language, so how you write the pipeline. And we can see some examples of that more later. But I want to touch on now the other part of Nextflow, so not the script section, and I want to touch on the deployment section, so how these things are run and the different ways that Nextflow can essentially run and parallelize the tasks. Okay, so the first way that we have here of doing it is, of course, you can run locally on your computer, just on your local machine. There's nothing particularly exciting that's happening there when you're running in this way. Nextflow can do that with or without containers. It's just going to fire off for every task a process inside your machine. What's obviously more common now, talking about the parallelization here in an external system, is the use of the centralized orchestration model. And in this model, Nextflow is submitting tasks to a centralized orchestrator. This is like a compute grid scheduler. So for example, like Slurm or LSF or Grid Engine. And in this way, Nextflow is submitting these tasks to the cluster. The task is running inside that location, and then it can be using something like a shared file system to have the input and the output data managed in this way. And this is very common for people who have large on-premise HPC solutions, or even some people who run in the cloud in this way. You can even have a scheduler on your local machine for doing that. It works very well where you have shared resources which have to be kind of divvied up and shared across an organization. Here's the local execution, which I mentioned before. And then there's a couple of other more complicated ways of doing this on-prem as well, where you submit Nextflow as a driver job. This is kind of only really used in specific situations where there's limitations around the scheduler that you're using. But what's become really popular is this kind of cloud batch orchestration. And the reason for this is a way of almost having a cluster in the cloud. But there's one great benefit of it, is that when you're not using it, it scales to 0, which means you don't pay anything for using it when you're not using it. The way Nextflow works here is it's submitting its job. So each of those tasks could be 5 for your pipeline, could be 50,000 to the batch API. The batch API then spins up a virtual machine for you, runs that task, and then the task is finished. And the data now has to go through what's called object storage, so S3 bucket in this case. But there's various different options for doing so. There's also ways of doing this with a shared file system. And finally, we also got the similar thing for Google, for being able to do this with Google Life Sciences, and Kubernetes, which is becoming really popular. And Kubernetes is a kind of way of what we call cloud native data pipelines, or cloud native orchestration. And it's a way of using the Kubernetes driver in this case. So Nextflow submits itself as a driver pod, and that spins up virtual machines on the go. It's a kind of protocol and a language for being able to do this in a way which is agnostic of the cloud vendor. So it's not specific to a specific cloud, and you can even have your own Kubernetes clusters and installations on premise as well. Okay, the practicality of this, how does it look like? So I said before, you have an Nextflow script which you run, and then that you can run these things in different infrastructure. So if I just write Nextflow run my script, it's going to run on my local machine. However, if I wanted to run this, say, on a HPC system or some distributed infrastructure, I could say, okay, Nextflow run And now I want to put in a config file the definition of where that should run. So in this case, I would want to say that there's a process. So the processes, but basically all of my tasks, should run on Slurm with a given queue with some amount of memory and some amount of CPUs using a specific container. This is the kind of abstractions which we have applied to Nextflow. And Nextflow will then submit that job using Slurm. So the Slurm like sbatch command to that queue, and it will convert this 8 gig, 4 CPUs, etc., into Slurm language as a Slurm submission for each of our tasks. If I then wanted to take the same pipeline, and no, I won't change anything in my pipeline, I won't change any code, but I want to run this now in the cloud, I can change now the executor to be AWS batch. And it has the same abstractions, so it knows how to convert 8 gigabytes and 4 CPUs into AWS batch language using the AWS batch API. And that's the kind of magic here, is that you're able to share your pipeline, and the user themselves or the developer who wants to run that on different infrastructure just needs to know a little bit about their infrastructure and nothing about your pipeline. This is just stressing again that decoupling of the pipeline from the configuration, which is really important. Now, one thing we haven't mentioned here, and one thing that really enables and drives all of this is containers. And I'm sure you've all heard of containers a lot before, but I think it was really insightful of Paolo way back in 2014. He was watching some talks by people who were using containers, and these containers at the time was really started to become popularized by Docker. And as part of that, they were using these containers for web services, so like long-running web jobs that were kind of running up there, performing some kind of service-like application. And Paolo really realized that if you took that idea and you could apply it to the use of pipelines, to the use of these tasks that we wanted to do, we could achieve something very similar. These containers have some advantages over the likes of virtual machines. So they spin up really fast. They're immutable, meaning they don't really change. You can compose them, so you can build these containers by building on a previous container. And as well as this really nice tooling around using them, much more, say, standardized than there was for virtual machines. And the way that it works is now when Nextflow submits a job, submits a task in a containerized fashion, it's able to do so by submitting not necessarily the job itself, but it submits a container which runs that job. Why is this important? It means that you don't have to have your tools, your bioinformatics tool that you're actually going to use in that job, installed on the host system. You install them in the container, and then you submit the container as a job. And of course, Nextflow handles that part for you, because it can be somewhat difficult to kind of go through all of that material and do it. So when you start using containers, it becomes really kind of second nature to do so, and then I would really recommend using them always. It makes a huge difference to your ability to write these pipelines, and obviously to improve and get all those fair workflow characteristics that we're looking for. Okay. Final few things here on Nextflow, and then I'll jump into a demo and kind of show you some things live. So we have execution reports, which are very useful for summarizing all of the pipelines that you run and find some sort of generic information around about how they've gone. There's also text editors. So if you're a pipeline developer and you want syntax highlighting for your workflows, you can use these to kind of help you develop the pipelines and provide a little bit of visuals around that. And Nextflow is also a participating member of the Global Alliance for Genomics and Health. This is a working groups that are selected around for specifically the task execution and the workflow execution, which enables that Nextflow can be compatible with all of the different APIs for launching Zoom. One of those APIs, particularly the workflow execution API, is really around how can we have a standardized API so that we can submit and we know what a Nextflow pipeline should look like in terms of an API call. So we want to say, I want to be able to launch Nextflow pipelines in different platforms. What would that look like? As part of the community, community growth, it's been particularly growing over the last couple of years. And that's kind of been really driven by people all around the world. So not just people who contribute code, but also people who write pipelines, also people who are kind of active on kind of social media, on support channels, which we have, as well as just users themselves. So people who are just using these pipelines really kind of grown all aspects of the project. Where that growth has happened, obviously it's very, very kind of great for us to be able to see that this is also happening in places where the sort of industry has just big significance. So mostly in pharmaceutical companies, but also small biotechs, some clinical genomics providers. Increasingly, you're seeing the likes of these genomics being applied to healthcare. So those kind of healthcare providers now are participating in developing these kind of workflows, which provides us with lots of kind of insights and ability to kind of keep growing and ability to kind of support the project long term. Another thing I'd like to point out here is some of the community efforts which have come around Nextflow. So as I said before, when you have an open source project, typically you think of contributors as people who commit code, people who write stuff and they add it to your GitHub repository. But in Nextflow, I think there's a slightly different case here in that the Nextflow community and the real strength of the community has come about not specifically through the contributions to the Nextflow code, but to the contributions of pipelines themselves. And the great thing about it is that if I write a pipeline and I share it with you, because of the principles that we spoke about before, you're able to run that as well. So there can be now a way for all of us to collaborate, for us to bring like the brightest people together, the experts on particular fields, and they can be really focused on a particular pipeline or even a particular tool or a particular part of that pipeline, can work on it collaboratively together, and then we all benefit from that work that we do together. And NF Core is a fantastic example of this, of building these community effort, community effort to build these Nextflow pipelines at a very high standard. These are used in production by facilities all around the world. And it's kind of testament to the fact that this project is really growing. I'd recommend that you check this out as well. We also received money from funding from the Chan Zuckerberg Initiative for both Nextflow and NF Core recently as part of this. Okay, so that's the bits on Nextflow so far. And I just wanted to also show you the other kind of extensions that we're working on beyond Nextflow kind of itself. So there has been like, in talking with users over many years, there were still some limitations around what you can do with Nextflow. The reason being it's a single user tool. It's a command line tool. This eliminates some people. It's a single execution tool, meaning that you can just launch one Nextflow pipeline with one Nextflow command. And what we wanted to do was expand that to really be able to build these things for other people. And this is what we've developed Nextflow Tower for. And Nextflow Tower is like a management layer above your Nextflow pipelines. So Nextflow Tower enables you to monitor several pipelines that are running. It enables you to launch your pipelines. And increasingly, it's going to enable you to work as a team to collaborate on these workflows as they go through and really help you with the deployment of those. So Nextflow Tower has an open source version, which is available on GitHub, but it also has a free version, which I'm going to show you now on tower.nf, which is free for use for academics and the like. A business model here is that we sell Nextflow Tower into companies such as pharmaceutical companies and biotechs for the deployment in their own environment. And just full disclosure on that one. So you can go up and it's free to sign up to use Tower. This is at tower.nf. The point of this is that you have an ability to have a centralized location for your pipelines. So when you sign in here, you can sign in with any authentication that you like. I'm just going to be using my GitHub here. And the first thing you see is on the left-hand side, a history of your executions that you've run. So you can see that this is an RNA-seq pipeline I've run. You can see the command line, which was made up of that run, parameters, configuration, as well as an execution log on that. So this is the actual execution log of the pipeline. But importantly, I can go through and see some general information. So how it was run, which executor. You can see this was in the cloud. You can see the number of tasks which are running live. And then you get some information on the statistics. So how long it ran for, the CPU hours, how much it cost me, etc. To run this. What's really nice here, though, is the ability to jump in and see specific information about a task. And what I mean by this is that when you run in a distributed manner, very often those tasks will now be deep down inside some working directory. They could even be in a different machine. They could be in the cloud on a bucket. And it's very difficult to manage those and sort of find out if you get an error, what the error was. So with Nextflow Tower, we have a full history of all of those tasks. So I'm able to go through and find a particular one, search for something. Maybe there was an error in this task. I can see what the command line was run. So this was GTF to bed tool. You can see where it was run, information on the execution, the resources that were requested for that task, the resources that were used. And I can jump in now and able to find some information on the execution log here. So I would be able to see if there was an error here. It would be able to present it to me in a way that I could access it, work on it, and then even resubmit the pipeline. So imagine that I wanted to fix something here. I could simply say, relaunch this pipeline and run at a different time. Okay, so that's the kind of basics of the monitoring of the tool. And this is kind of become very popular for using it, but we wanted to take it to the next level. We wanted to say, okay, how can people take this tool now and run these pipelines who are not familiar with Nextflow, who don't really know command line? And for this, we developed this way of launching these pipelines. So you can choose a compute environment. You can set these up before. So you can see I've got several of these set up. You can choose a pipeline that I want to launch. In Nextflow, all pipelines are Git repositories. So this is just public Git repos that I want to run. So let's say I want to run the same one I had before, RNA-seq. Then I can choose a revision. This is taken from the Git commits or the Git tags that I have. So in this case, this is all using the API to pull up the actual revision that's available to me. So let's say I want to run version 3, and I want to run it with some specific profile. So I want to run it with a test profile, say. I could insert some parameters here, but typically what I want to do now is just launch that pipeline. And what's going to happen here is that Nextflow is going to submit that job, the Nextflow job, into a queue, and from there it's going to be running in the queue in the cloud of my choosing. I would recommend if you want to have a look, you can go through here. There's a whole bunch of documentation on this at help.tower.nf. Can share the links with you after this, which kind of describes a little bit how you use this, how you can set this up. Important to note that you can also use Nextflow Tower both from just the command line. So if you're already running Nextflow, you can say Nextflow run with Tower, but you can also create compute environments for example, on-premise deployments. So for Grid Engine or LSF or Slurm, if you're using any of those. Okay. I'd like just to take a moment now just to highlight the NF Core project. I said it's been a really instrumental part of growing this. Here is a bunch of the pipelines that you have available to you. These are all available for being able to run directly from here, or you can just copy the repository name and copy paste that into Tower if you like. These are all Git repos. So everything here is worked on inside GitHub. So if I was, for example, select here, you can see that there's all these people who have been working on this pipeline together. I could go view this inside RNA-seq here, view the code which is getting committed, and launch it. I think I'm just about out of time on that, so I think I'll just jump through to a few of the final slides on that. So I'll just change screen here. So I'm just highlight a few of the other things that we have inside inside Tower and that we're working on. Collaboration is obviously a really big thing of this. So you can now take the pipeline execution and share it with a collaborator. They can view live that pipeline as it goes through. Also being able to relaunch that pipeline. So some of the features that we're adding in is the ability for users to have teams. And inside those teams, you can have members of your organization. You can have workspaces where you're working these pipelines for, and even a pipeline launchpad feature, which renders the input parameters of a pipeline into a form for you so that then users can come in, read the documentation, and really just launch those pipelines in a pre-configured manner. There's documentation on this, and there's also an API for doing so. So I'll finish there. Maybe I'll have a look at this, some questions that we can go over together. Thank you. Okay. Did you have any questions that I?
Yes, Hi, Evan. There's a question from Harriet, and I think it was based on your demonstration now. Harriet, go ahead and ask your question. I see your hand is up, but you also tapped it in the chat box. But go ahead, Harriet.
Hi, Evan. Thank you for the talk. It's and thank you for Nextflow, both to you and Paolo. It's amazing. It's very essential for the work in our group. So I just have two questions. The one is, when you went through Nextflow Tower just now, you launched it and pulled it from GitHub, but where did the input and output data go or come from? And my second question is, in terms of development of your Azure executor, batch executor, how far is that?
Great questions, great questions. Let me share with you the first one around the data that we use for this. So one of the principles that I said at the very beginning was around having a small test data set which you can run. And this is kind of goes back to the idea of scalability and testing your pipelines. What we like to do is inside our pipelines here, and this is the exact pipeline I just launched, we have a configuration which is pointing to a small test data set. So in this case, if we look at the Nextflow config here, you can see that we had a small test data set when I run with batch, which is just pointing to a single sample in an S3 bucket. So here you can see that this was a chicken sample for lung. It was using this transcriptome file here. So those were the two inputs there. Now, obviously I can override those. I can define what those are in Nextflow Tower in the parameter field. So I would say reads equals something else. The next iteration of this is to actually render all of the parameters inside a JSON schema, which then gets converted into a form. Now, you can actually, this is very new work, which is going to be coming out in the next couple of weeks. This is a lot of this work was done with NF Core, but essentially it's a way that you can create a schema. In this case here, you can see what it is. And this is basically going to say, okay, this is an input, all these are the input output options. This is a reference genome, and it defines exactly what it is. And you can add some descriptions here, which are rendered inside of that form. You can have drop downs, you can have buttons, etc. for users, and that enables them to do that. Next question in terms of the Azure executor. So that's actually very well progressed. The timeline for that is to have a preview of that in February. And we will be organizing public webinars on that, sort of announcing that probably in the next month or so. We'll be showing off the prototype of that very shortly. It's come along very well. We're very pleased with it, and I think it's going to be a really good addition to really have all of the three public cloud providers on the Nextflow ecosystem.
Okay. Harold says thank you.
Cool.
I think you were done with the slides, right? Evan, because I don't want to rush.
Exactly.
So we're done with the slides. We're done.
Absolutely.
Okay, sure. Okay, thank you so much for that. The demonstration was very interesting, so thank you. It's now question and answer and discussion time. So please, if you have any burning questions, please do raise your hand or tap in the chat box, and I'll read it for. Okay, Owusu, go ahead and ask your question.
All right. Thank you very much for that presentation, Evan. It's my first time getting to have a go at this Nextflow thing. And it's quite interesting what you just shared with us here. Now, I was wondering, definitely there is when you get like the folder you're talking about and just go and one command and it runs, definitely there are tools in there that are versioned. So is it like, can these tools be automatically updated to newer versions, or does one have to go and hard code those versioning of the tools that are inside somewhere inside the code, or how does it work?
Yeah, it's another good question. It really comes about, you have kind of a lot of flexibility in Nextflow, the way that you version your tools. Originally, and I guess like the most common way of doing this before DSL2 was that you have a big container, and this container you build once or many times, but typically once. And then that container has all of the tools in it, which are a specific version. And you use that container for all of your pipeline. So if you have got in there SAMtools and Bismarck and FastQC, when you run SAMtools, you still use the same container, even though it's got all of that software installed in it. That's the first part. What we've done, and you can kind of imagine how you update that. So you have to update the whole container, and then you update the container in the configuration. What we've done with DSL2, which enables us, at least in an easier way of doing so, is that each task, or sorry, I should say, each process can have its own container. And in this case, the process is made up of, you can think of the command line which you run, or the script that you run, as well as the container itself. So it's those things together, which when combined, really provide you with the ability to version control that. Now, there's nothing specific in Nextflow which is performing that version, which is kind of performing the version control on the tool level for you. However, you're more than welcome, and looks like this is kind of a way they're doing with NF Core, is to have a Git repository specifically for modules that you reuse very often. And then, for example, just when you update a container, you can put a version number as a tag on that container. So this is SAMtools version XYZ. And then when I update that, I create the container with a different name. And then that gets pulled into my module identifier for doing that. So then the module will call that specific version. That's the kind of way we've got at the moment. There is some work that we'll be doing later on this year around building these containers on the fly. And in that way, then we'll be able to provide a little bit more information and a little bit more detail on the versioning of tools specifically in a kind of much more automated build fashion.
Okay. Thank you so much for that question, Owusu. There's another question here in the chat, Evan, from Gilbert Kibetron, who's saying, is it possible to publish a Nextflow pipeline like the RNA sequence or RNA-seq in a peer-reviewed journal? And the follow-up to that is, if yes, what are the QC checks one needs to have besides NF Core? Thank you, Evan.
Sure. It's 100% possible to publish these papers, and this is becoming increasingly popular with people who are developing complex pipelines and they want to kind of work on this and get credit from it from an academic perspective. I think it's something which is kind of more new. Typically, you were thinking that people were either publishing some analysis, so some results and some kind of meaning for it, or they were considered tool developers, like they write a specific tool that does something. Now, pipeline developers is almost like a more of a new, say, a new occupation, but it's become an incredibly important one. And as part of that, there is even journals which are specifically accepting this. I think that there's, I can't remember the name off the top of my head, but one of the new NAR publications has a section specifically, or is adding a section specifically for workflows and for pipelines. In terms of what the QC tests are around that, I don't know specifically. I think that would be reviewed in a normal standardized way. The key things are, of course, to make everything, if you kind of follow the golden rules of creating pipelines, so making sure everything's open, you're using containers, you're not kind of hard coding things, you're creating small test data sets, you're using version control properly. All of those are the things which will be, I would think, would be assessed on a kind of QC basis for publication. So yeah, I think there's a lot of opportunity here, and it's a new thing, but there's going to be a lot of moving ground, and so very cool to see.
Okay, thank you so much for that question, Gilbert, and thank you, Evan, for your answer. We are a bit pressed for time, so I'm just going to ask that we have one more pressing question. So if you've, okay, there is a simple question which I'm going to ask now from Husimidin Osman, who's saying, just a simple question. Have NF been, or rather Nextflow, been designed for fairness? And what are the future upgrades to account for that?
Yeah, so to be honest, when we created Nextflow, I don't know if how much fear was around, or how much it kind of became very popular afterwards. For sure, now it's kind of part of mainstream scientific analysis. We definitely were focused really initially on the reproducibility part, and this was one way that we were able to get high impact publications, was based on that. But the other aspects of FAIR, we're obviously big supporters of it in doing so. So making things findable, this can be done through the likes of Docker or GitHub. So Docker, not Docker Hub. There's one. basically a doc store, which is a way of finding Nextflow pipelines. Obviously, the interoperability really comes about from all of the cloud platforms, which we try and provide there. The ability to make these things reproducible is so, and also the accessibility of that. So it wasn't designed in it specifically from FAIR, but it's very inspired by it, and it's definitely kind of using all of those principles, and really I think is a big part of fairness, at least in terms of data pipelines.
Okay, thank you so much for that, Evan. And Paulo's adding his bit there, saying fairness is more data related. However, Nextflow is definitely inspired to fairness principles. Thank you so much for that, Paulo. Okay, I'm looking at time, so I'm just going to ask that if you have any questions for Evan, please, or Paulo, please do email them. Evan's email is evan@seqera.io, so you can send him an email if you have any questions. I'm going to send the slides and the link to the recording. Our YouTube channel has all our webinars that we host on there as well, and I'll send you the link to this recording for today's webinar. And I'm going to ask that if you're on Twitter, please follow him on Twitter at Evan Floden, or follow Seqera Labs. Twitter is very important for science communication, so do not take it for granted. But yeah, so Evan, thank you so much to you and Paulo for agreeing to do this, give this webinar, which is our first webinar for 2021. We're really grateful. And thank you to Scott for putting us in touch, for linking us up with you and Nextflow people as well. So thank you so much for your time and effort. And to all of you, see you next month on the last Wednesday of February, and I'll send an email with the details about who the speaker is going to be. But yeah, we're going to have a webinar every month going forward, and I just want to say we are truly grateful to Paulo and Dr. Evan as well. Enjoy your day, everybody, and see you next month. Goodbye, everybody.
Thank you all. Take care.
Bye.